Hello, this is Rutman Meyer again for NCMS with another screencast. This time I'd like to talk about the hierarchical cluster analysis. This is a cluster analysis that you can do when you have a bunch of variables that are binary or that are at the nominal measurement level. So earlier I talked about a k-means cluster, which is fine when you have a scale measurement level like interval ratio or something very close to that. So for instance, when you've measured stuff with big Likert scales or just measured something as a quantity rather than as a category response to a particular question. So here we have an ability to make clusters based on yes or no answers, something being present or being absent. So it's the same data set as before, and I mentioned in the previous podcast that we didn't want to do these types of things in our k-means cluster, and that's not suited for that. So here's me telling you that there is a way to analyze this, to put this into clusters and use that. So this is for all you guys out there who are working on their full circle assignment and they had a questionnaire, and most of the questions that you actually want to segment on are binary questions like this, where the answer is either absent or present. And you didn't really have the ability to do the k-means cluster, you just do the hierarchical cluster instead. So here's how that works. Obviously, the steps are the same as for the k-means cluster. It's a 3-step process. First of all, you think about the variables you want to segment on. You do not want to segment on everything. You want to select a few that it's logical for you to segment on. You don't want to segment on stuff like age, region, address, and income if that's not relevant for you. What's most likely relevant is how people use your product, or what sources people use, what type of content they're interested in. Segmenting on that so you can identify the personas and cater content to them. And then afterwards, once you've identified those clusters, you can say, okay, now I really want to describe those clusters, and you just look at the descriptive statistics for each cluster. So here we go. It's pretty straightforward. It's in the same menu as the previous one. So that's analyze, classify, and then hierarchical cluster. It's below the k-means cluster. And this is what you get. It's an overview of all the variables that you have and the ones that are interesting to you. So I already moved them over here. Standard default settings will put this on cases. We don't actually want to cluster cases here. We want to cluster variables. So it's still about people that belong together, but I actually want them to know which variables belong together, and not which people belong together. Because I'm getting that information anyway. I want variables. I want some statistics. I want some plots. Which statistics and which plots? Let me show you. Again, these are the variables that I want. All binary. Do people have multiple lines? Yes or no? Do they have electronic billing? Yes or no? Do they have wireless service? Yes or no? The statistics that I'm looking for is actually just this one. The agglomeration schedule, and we'll look at the output as to what that means actually later on. For the plots, I want a dendrogram and none of this other stuff. A dendrogram is a sort of a graphical way to show clusters. It looks a little bit like a schematic of a tree. That's why the word tree is in there. At least not the English tree, the old-fashioned tree. Most important bit is here. This is which method you use. As you can see, you can pick from many, but we want this one. And here we can do different things for when we have different type of data. Right now we have binary data, remember? Yes or no. A yes being a 1, a no being a 0. If you have 1s and 2s, do not forget to make it so here that 2 is absent, for instance. Again, we have many different people who gave their name to a very interesting way to do stuff. The thing we need to discuss right here is, like, the standard thing would be to do simple matching. And all these other things are sort of variations on that. Simple matching is what it is. It puts things together. If you have a thing and you also have another thing, that's similar. But what simple matching also does is when you don't have a thing and you don't have another thing, that's also similar. So it puts people together in clusters over there as well. And that's a bit weird. Let me try to explain this with an example from music. So let's say if I were to use simple matching, and I asked a bunch of people about like what bands they like, and it's a big list, and one of the results would be that people like Queens of the Stone Age, and they also like Foo Fighters. And that's fine, because the music these bands make sort of is similar. It's rock music. I don't know, some could say a little bit of stoner rock for Queens of the Stone Age. And they call it robot rock themselves, but at least it's rock, and Foo Fighters, as you know, one of the biggest rock bands in the world. So that those are clustered together makes sense, because they are actually similar. They make similar music. If there's a bunch of people who do not like Kanye West and who do not like the Beatles, this simple matching algorithm puts those together in a single cluster as well. But the things you do not like actually are not really similar. Yes, they're both about music, but that was the whole idea, that all the questions were about bands and music. They're not even in the same genre. It's really different kind of music, so it would be really weird to say, okay, this stuff that I have zeros for, I don't like it, is similar by itself. So that is where simple matching may sometimes go wrong. Dissimilar stuff being actually made similar because people don't like it, but obviously people dislike it for different reasons. And you dislike the Beatles for a particular reason, and you dislike Kanye West for a particular reason, and they might be different reasons. A way to get rid of that is by using the Jacquard method, and that actually just says, okay, if things are present in both cases, then they belong together because they're probably similar. And if things are absent, we don't, and they are absent in two groups, we don't automatically cluster them together. That's the only difference. So it's about half the simple matching strategy. We then press continue, and we press OK, and this is then the output we're getting. Just a lot of blah blah. This is the agglomeration schedule, and what it shows is how many clusters we're trying to work with. This dendrogram actually shows you the same process. You start with a lot of different clusters. Every variable is its own cluster, and then it starts to group things together, and grouping it together, and grouping it together, and grouping it together. And this is the end state, basically two big clusters. And this is just a different overview. Basically, what you need this for is the looking at the coefficients here. So this is the start, and how long we continue by the process of trying to cluster everything together. And what you need to look at is these coefficients. Are there any big jumps here? And mostly you're looking for jumps of increasing stuff. So a jump from 2 to 5 or something, or from 5 to 20, those would be really big jumps that can inform you. Looking at this is not really informative at all. So in this case, we can just skip it for this data set. Remember, it's actually the same as this. This is visual. This is a little bit more quantitative. It shows you the same process. And you can use both to inform you about what's going on. You may have noticed this is a fixed pattern in all the analysis that we do. We always try to visualize it and quantify it, and then use both to figure out what's going on. If you just have the visualization or just have the table with the quantities, then that by itself is not enough. You need both to understand fully what's going on. So let's take a look at this dendrogram. And this dendrogram shows us that there is actually a few clusters that are interesting. The clusters that are interesting, so that's stuff that belongs together. So if we look at so what is actually a cluster? That's a bunch of things together. And in this dendrogram, we're looking at big gaps here. So definitely here are two clusters. This cluster entails everything here, and that cluster entails everything over there. So this is a rather coarse resolution of the model. We only have two clusters left. We can see a cluster with the internet and probably the modem you use for the internet. That if you have that, you also have electronic bills, which makes sense, and you have multiple lines. So that belongs together. In people who are customers of a telecommunication company, these are the services that they have together. And here are all the other things together. So that's a bit coarse. Maybe we don't need to look at like 2 clusters, but maybe 4 is a better thing. You can see that multiple lines actually is a separate thing, but internet and equipment, probably a modem, and electronic billing is a cluster that is together. These 3 things belong together in this particular cluster. Then we have another cluster here that says having a pager, wireless, and voicemail. And basically stuff about being reachable when you're in fact not reachable, but that you're aware of what the person was trying to say to you anyway, belongs together in a particular cluster. And here we see the final cluster where we have a calling card, which is a little bit separate from the other stuff, and then call waiting, toll-free calling, caller ID, and call forwarding is also in a cluster together. So this can identify to you which things, which part of your services in this example your users are using together. So what things co-occur, and if they co-occur, what things do they not occur with? So what things are homogeneous with themselves and at the same time heterogeneous with other things. Well, you can see that this particular cluster occurs together, and by all means, yes, it's very logical that having internet and the equipment for the internet and electronic billing at the same time, that makes sense, but that's also why I'm using this example, because it's straightforward. So it might be that in your data set there are certain properties that you measured with variables of a nominal measurement level that have a binary outcome, absent, present, yes or no, that they co-occur, and that you can find clusters like this. The next step, obviously, again, would be to figure out which people are in these clusters, and then doing demographics and psychographics on that. Alright, so that's it actually for the hierarchical cluster analysis. It's just a quick picture you can paint about which things, which variables that you have belong together, and that you can use to classify your data into different clusters. If you choose to use this, or if you have to use this, good luck. And if there are any further questions, please feel free to come and see me. Thanks for your attention. See ya.